Okay, welcome back everyone. So in this lecture, we will try to design a circuit that can use both the the negative cycle of the input voltage and the positive cycle of the input voltage. But we will have to be clever in designing this circuit because we don't want our output to have two polarities. Okay, we don't want our output to have two polarities. We don't want this because, well, we are trying to convert AC to DC, right? But DC signals have only one polarity. Okay, DC has only one polarity. It always a DC voltage supply or a DC source always supplies voltage or current in one direction. Okay, so what do we want? We want to use both the negative cycle and the positive cycle, but we don't want two polarities. Basically, we want to convert the positive cycle to one polarity, and we want to convert the negative cycle to the same polarity. Okay, I have been talking about polarities for a long time now, so let's see how we can design a circuit. So design this circuit. Okay, so all right. So suppose I have some AC source. Okay, I have some AC source. I will draw it like this. And I have some load resistance. All right, I have some load resistance. Okay, since this is an AC source, let me name these terminals. Suppose I will call this the terminal 1 and this will be the terminal 2. Okay, so the voltage of these two terminals will fluctuate. Sometimes the terminal 1 will be more positive than the terminal 2, and sometimes the terminal 2 will be more positive than the terminal 1. Okay, so sometimes current will this voltage source will try to supply current in this direction, and sometimes it will try to supply current in the opposite direction. Okay, all right. So what do we want in a rectifier? We want that no matter in what direction the input voltage source is supplying the current, our output will have current in only one direction. Okay, our output will always have current in one direction. Okay, we want to do this. So how can this be done? Well, suppose in the positive cycle, when in the positive cycle, when the terminal 1 is more positive than the terminal 2, okay, if we connect our circuit like this, then in which direction will the current go through? Can you tell me? Well, we can, this is quite easy to see from the diagram here. Draw that carefully. Okay, so we can see from the diagram here that the current will flow through this direction, then it will go to this direction, then it will go through here, it will go through here, and it will go back. Okay, so notice this direction. All right, notice this direction carefully. What is the direction of the current here? The direction of the current is downwards. Okay, all right. Now suppose our voltage source, this was the positive cycle, our voltage source reverses its polarity in the negative cycle. Okay, it reverses its polarity in the negative cycle, and I have my load resistance here. Okay, so in the negative cycle, this terminal is more positive than this terminal. I will again name this 2 and 1. Can we connect the circuit in some clever way that the current flow through R remains the same? Can we do that? Well, it's actually quite simple. If I connect the circuit like this, suppose, well, since this terminal is more positive than the terminal 2 is more positive than the terminal 1, the voltage source will try to supply current in this direction, all right? Okay, so if I connect the circuit like this, then how will the current flow? Well, we can trace the steps of our current. The current will go in this direction, and then it will go in this direction, and in this direction, and this direction, and this direction, and it will go back. Okay, now notice the direction of the current again. Okay, notice the direction of this current again. What is the direction in which the current is flowing? It is again flowing downwards. So we have what we wanted. Okay, we are allowing current to pass in both the positive and the negative cycles, but the output of the current, the direction of the output current did not change. Okay, but you might say, well sir, these are two different circuits, so do I need to connect to two different circuits during the positive cycle and another time in the negative cycle? Do I need to know that manually? Then what is the point of making an electronic circuit? Well, we will not do this thing manually. Okay, we will design a circuit that will do this task for us. How can we design a circuit like this? Well, in the first circuit, since we want the current to flow in this direction only, we can achieve this by connecting a diode. Okay, we can achieve this by connecting a diode in this direction and in this direction. Okay, and in this circuit, since we want the current to pass in this direction, we can perform it again by connecting two diodes. Okay, but still you may say that, sir, this is still two different circuits. Well, can we combine these two circuits? Can we form some mechanism to combine these two circuits? Yes, we can. So what will the combined circuit look like? Okay, let me move to the side to show you what will the combined circuit look like. So I will draw my voltage source. All right. Then the first circuit says that I will need diodes here and here. Okay, so let me draw the diodes. I have one diode here and one diode here. Okay, and the second circuit says that I will need diodes here and here. Okay, so I have one diode here and I have another diode here. Right, I mean, I just combined the two circuits. Okay, I am just drawing what the upper circuit has and the lower circuit has. Okay, and what is the other things that the upper and lower circuit has? Well, the upper circuit is connected here, so I will connect these two parts. Okay, let me use another color here. I will connect these two parts, and the lower circuit is connected here, so I will connect these two parts and I will draw the load resistance. Okay, this is RL and this is our input. Let me explicitly name the terminals again, 1 and 2. Okay, so now we have a single circuit that operates like these two circuits in two different cycles. In the positive cycle, it operates like the upper circuit, and in the negative cycle, it operates in the lower circuit. So let's explicitly work out how these two cycles work in this final circuit that we have. Okay. All right. So suppose in the positive cycle means that the one terminal is more positive than the two terminal. Okay, so in the positive cycle, the voltage source will try to supply current in this direction. Okay, it will try to supply current in this direction. All right, so the current arrives here. Let me draw with an arrow. The current applies at this junction. Okay, so in which direction will the current go? There are two diodes at this junction. The current can go either in this direction or in this direction. Will the lower diode allow the current to go in this direction? Will the lower diode allow this? It will not, because this lower diode will only allow current to pass in the upper side. Okay, so this diode will not conduct, this diode will conduct. Okay, so let me just erase this part. All right, so the upper diode will conduct. If the upper diode conducts, then the current comes here. Okay, the current comes here. Now at this junction, the current again has two routes to go. The current either can go in this direction or the current can go in this direction. Now, will this diode allow this current to flow? It will not, because the diode does not allow current to pass in this direction. Okay, does not allow the current to pass downwards. So I will again erase this. So the current will go in the other direction. Okay, so the current goes in this direction and it passes through the resistor, here, and it comes back. Okay, now at this junction, the current again has two roads to go. Okay, it can go through this diode or it can go through this diode. Okay, first of all, if the current comes out of one terminal of a voltage source, it has to return to the second terminal. Okay, and so we can guess that the current will go through this one. Okay, but why doesn't the current go through this diode? This is because if a diode has to conduct, if a diode has to turn on, then the anode of the diode has to be more positive than the cathode. Okay, that means the voltage of the anode has to be more positive than the voltage of the cathode. Okay, but this plus here, this is the most positive voltage of the circuit. When the current has flown through this diode and come to this wire and passed to this resistance and this resistance, the voltage, a lot of voltage has dropped. Okay, so there is not enough voltage in this point at this terminal to cause this diode, this final diode, to turn on. Okay, so what happens is this diode is still off and the current actually cannot turn this diode on. The current passes through here, it goes to here, it goes to here, it goes to here, and it returns through this terminal. Okay, so what is the path of our current in the positive cycle? The path of our current is, you can see, like this. Okay, the red lines that I have drawn, this is the positive cycle. All right, so What happens in the negative cycle? Let me just copy this figure. Okay. Okay. So what happens in the negative cycle? Let me just delete all of this. Okay, so in the negative cycle, this terminal is more positive. I mean, terminal 2 is more positive than terminal 1. Okay, so the voltage source will try to supply current in this direction. Now we will just repeat what the arguments that we had in the previous circuit. All right, so this is the negative cycle. So the voltage source supplies current in this direction. At this junction, which diode will conduct? Can the current go downwards? Can the current go downwards? No, because this diode will not allow the current to go downwards. Okay, this is not allowed. So the current will go upwards and it will go here. Similarly, at this junction, this diode won't allow the current to pass. So the current will go forward, it will go forward, it will go through this resistor, it will pass through the resistor, it will come here. Okay, now the current, since the current originated from the terminal 2, it has to return to the terminal 1. And for the same logic that we saw previously, that this voltage is this voltage is lower, the voltage of this terminal is lower than the voltage of this terminal, so this diode will not turn on. Okay, this diode will not turn on, and the current will pass through here, and the current will pass through here and return to the terminal 1. Okay, so what path did our current take now? Let me remove the other paths that I drawed. Okay, so what is the path that our current took now? Well, you can just notice the blue arrows that I drew. Okay, like this. Okay, so if I just compare with the previous one, you can see that the current through RL was in the downward direction, and in the negative cycle the current through RL is also in the downward direction. Okay, so we have current flow in both cycles. In the half wave rectifier we had current flow only in a single cycle, but in the full wave rectifier we have current flow in the positive cycle and we have current flow in the negative cycle. Okay, so if I try to draw the output, what will be the output? Okay, what is the input of this circuit? What is the input voltage of this circuit? The input voltage of this circuit is this one. Okay, this is V in. And what is the output voltage of this circuit? This is V out. All right, this is V out. Okay, let me take some more space. Okay, this is V out. So what is the graph of V in? The waveform graph of V in. Okay, this is the waveform graph. What is the waveform of V in? If I have a graph, this is VA. So sorry, the thing that we are plotting, you have to keep that in the y-axis. This is V in and this is time. The graph of V in is, well, the graph of a normal sinusoidal signal. All right, okay. So what is the graph of V out? Okay. So in the positive cycle, what is happening? In the positive cycle, current is flowing to this direction. Okay. So you can see that in the positive cycle, if I look at this circuit, the terminal 1 is connected to the upper part of RL and the terminal 2 is connected to the lower part of RL. Okay. So the positive cycle is passed as it is. Alright. The positive cycle is passed as it is. Okay. What is happening in the negative cycle? In the positive cycle, the terminal 1 was connected to the upper part of RL. In the negative cycle, the terminal 1 is connected to the lower part of RL. Okay. So actually the input voltage, when it comes to the output, the input voltage has flipped. Okay. Because of this flipping, in both cycles, we have current flow in the same direction. In the positive cycle, current flows through RL from top to down, and also in the negative cycle, current flows through RL from top to down. Okay. So for the negative cycle, we have the voltage output like this. It is also positive. Wait, draw that properly. Okay. Okay, similarly, and this pattern will repeat again for the other cycles. So what has happened? So for both cycles, we now have current conduction. Okay, the positive part of the cycle passes as it is, and but the negative part of the cycle is flipped. Okay, so the voltage that we could not use in the half wave rectifier. Okay, in the half wave rectifier, what did we have? We had voltages in the input part of voltages in the input part during the negative cycle, but that voltage was not coming to the output. Okay, now that voltage, we have devised a clever circuit that converts that voltage from negative to positive and supplies to the output. Alright, so this, since this rectifies both the negative part of the cycle and the positive part of the cycle. Okay, this rectifies the full wave of the input. This is called a full wave rectifier. Alright, this is called a full wave rectifier. Okay, this also has another name. Okay, this is also called by another name. As you can see, this configuration. Okay, notice this configuration. What is this configuration? Well, we have two branches of devices. Okay, we have one branch, one diode branch like this. This is, we have one diode here and one diode here, and another diode branch, one diode here and one diode here. Okay, and we have connected, we have bridged these two branches. We have made a bridge between these two branches using the voltage source. Okay, so this is actually a bridge circuit. You have actually learned about bridge circuits in your school or college before. The bridge that you learned was a resistance bridge. Okay, suppose I have, in place of diodes, I have a resistance here and a resistance here and a resistance here and a resistance here, and I connect some galvanometer or something, some device as a bridge between these two resistance branches. What was this bridge called? This bridge was called a Wheatstone bridge. Okay, you might remember from your HSC days or SSC days. Okay, so we can actually make bridges from different types of elements, not only resistors. Here we have made bridge from a diode. So since this rectifier is made using a bridge circuit, we also call this rectifier a bridge rectifier. Okay, a bridge rectifier. Okay, or you can also call it a diode bridge rectifier. It is the same thing. So this was the main operation of the full wave rectifier. Okay, So in the positive cycle, the current flows in this direction, and these two diodes are turned on. This diode turns on and this diode turns on. The other two diodes are turned off. Okay, this is off and this is off. And in the negative cycle, this diode turns on and this diode turns on. The other two diodes are turned off. Okay, but the clever part of this circuit is that no matter which of the two diodes turns on, current flows only in a single direction. Okay, from top to bottom of the RL. Since current only flows through a single direction, the output voltage has a single polarity. Okay, the output voltage only has a positive polarity. If we consider this as the positive polarity of the output and this as the negative polarity of the output, since current flows only in this direction, in the downward direction, the output voltage has only a single polarity. So we are using both the negative and positive cycles of the input voltage, but converting the negative voltage, negative cycle to a positive polarity cycle. Okay, so this was the workings of the full wave rectifier. So what will be the transfer characteristics of a full wave rectifier? As we saw before, for a half wave rectifier, in the previous lecture we saw that the transfer characteristics of a half wave rectifier was like this. Okay, if I have the input voltage in the x-axis and the output voltage in the y-axis, the transfer characteristics was when the input is positive, the output is equal to the input, and if the input is negative, the output is 0. What will be in this case? Well, for the positive cycle, I mean if the input is positive, it is the same as the half wave rectifier, alright. V out, V in. If we see the graph here, you see that if the input is positive, the output is positive and equal to the input, no change. So it will be the same as the half wave rectifier. Okay, this had a slope of 1 and this will also have a slope of 1. What about the negative cycle? Well, we can see that if the input voltage is negative, the output voltage is still positive. Okay, so for the negative cycle, the output voltage is the negative of the input voltage. Why? Suppose if this is minus 5 volt. For minus 5 volt, what is the output voltage? The output voltage is plus 5 volt. So how can we describe this? That we have a minus voltage in the input, but we have a plus voltage in the output. We will multiply the input voltage by a minus sign. Okay, so for the negative cycle, the output voltage is the negative of the input voltage. What is this graph? Well, this is the graph of y equals minus x. So this graph looks like this. Okay, this graph looks like this. Okay, and the slope of this part is minus 1. Alright. One assumption that we have made in this circuit, I should probably say that explicitly, that all the diodes are ideal. Okay, all diodes are ideal. That means when the diode turns on, it is completely short circuit, and when the diode is off, it is completely open circuit. But if we use real diodes in place of ideal diodes, okay, if we use real diodes, then there will be some loss in those diodes, some voltage drop across those diodes, and the transfer characteristics will not look like this. It will look a bit different. Similarly, the waveform characteristics, the waveform of the input and output will not look like this either. It will be a bit different, but it will be similar to this. Okay, so in the next few lectures, we will try to see what happens when we use real diodes in these rectifier circuits, real diodes in a half wave rectifier or a full wave rectifier, and we will try to derive some quantities or some formulas that we can use to describe how well does a rectifier perform. Okay, so thank you for being in this lecture until now. See you later. Okay, bye bye.